In this video, I'm going to go over the necessary concepts for written homework 1. With future written homeworks, I probably won't do as many videos as I'm going to do here, or for written homework 1. But because this is the first written homework of the semester, we're reviewing Calc 1. I want to make sure I cover everything that you need. All right, so with that in mind, let's see here. So in written homework 1, we're going to use the net change theorem. First thing just to notice is that the net change theorem is exactly the fundamental theorem of calculus, just rephrased a little bit. So here is our fundamental theorem of calculus, the FTC, fundamental theorem of calculus. And notice that this is an antiderivative. The capital F is an antiderivative. It's a function whose derivative is f of x. Now, if we, instead of putting f of x here, if we put f prime, if our function under the integrand there is f prime, then an antiderivative of f prime is f. Right. So the net change theorem is really just the fundamental theorem of calculus. Now, if you took Calc 1 at Boise State, then you've seen this symbol before. The change in f, that literally just means just another notation for this. This is the change in f. All right, so that's the first point I need to make. Next, remember, you've probably seen this from Calc 1, maybe in a physics class, but the setup here for this written homework is, so we have a cart rolling on a flat surface. There's a reference point. Let's say the reference point, I'll call it the start. There's a start. And S of t is the position of the cart. And v of t, which is s prime of t, is the velocity. And so, applying these ideas here, or these definitions here, to the net change theorem, we have something like, so s prime is v of t, so we have equals the change in s, otherwise known as s of b minus s of a. And so now looking at this cart again, the function s that tells the position of the cart with respect to our starting point. And velocity, this tells the speed and the direction. So velocity, you can think of as speed in a direction. And for us, for our setup here in this very simple setup, we have one of two positions. Either we can go to the right, which is positive, and to the left, which is negative. So with this in mind, the way I personally like to think of the net change theorem, especially in this context with velocity and position, is that and this is remember v of t is a rate, right? This is v of t is s prime of t. This is a rate of change. So really what the net change theorem is telling us here is that the area under the rate or rate function, this is equal to the change in position. All right, and now last thing I want to go over is conceptually. All right, now let's say we have, here's our graph of the velocity, our velocity graph, t and y, t. Let's give some arbitrary number, let's say 2 and 4 there. That goes right through there at 0. Okay. So let's look at this piece right here. Let's look at this area right here. All right, this is, so remember we could think of this as this is this area here. Now the integral is going to assign a negative to it. Remember from Calc 1 that area below the t-axis in this case, or the x-axis, the area below the t-axis here, the integral will assign a negative to that. Whereas the area above the t-axis will be a positive. All right, so this, so from 2 to 4, v of t dt, right, this number is going to be negative, right? This number here is going to be negative. Right, so remember this is the area, right? This is this total area here that I'm shading in right here. This is total area, but it also has a negative. It assigns a negative to that area because it's below. The area is not negative, but because it's below the t-axis, we assign a negative to it. That's what the integral does. Integral assigns that negative to it. Okay. Now, so that area, that shaded part there is negative. That's what I have written here. And so now think about what this means now. By the net change theorem, that says that s of 4 minus s of 2 is negative, right? Because these things here, that is equal to that. Those are equal, right? That's exactly what we have right here. All right, now doing a little math. Let's see if we add s of 2 to both sides. We get that s of 4 is less than s of 2. And where s is the position at time t of our cart rolling on a flat surface. And so now let's think of this. Here we have the position at time 4. Here we have the position at time 2. And so you can see the position as time increases. You think of this maybe as your start. You can see what happens. The cart moves to the left. At time 2, we're here. At time 4, we're there. So we're moving to the left. So the point here is that area within this context of velocity and position of this cart rolling on a flat surface, area below the t-axis talks about a change in position moving to the left. So below is moving to the left, above is moving to the right. So let me try and really hit home this point. This area here, this represents moving left. This area here represents moving right. So this is the cart moving right, all this. So this change, so think of like this change in position is the change in position moving to the right. This change in position is change in position moving left.